Hello guys, welcome to my channel Vivek Pandey, and I welcome you all to my playlist, which is Lead Code Vivek Pandey. So on a daily basis or on a weekly basis, I'm uploading a video of explanation of a question from a lead code, guys. So till now, how many we are done? Total six questions are done here, and today it is the seventh question I'm going to solve. Okay, so if you have not seen all these, please go and just visit it. Try to learn if you can understand something from this. Okay, and so now we are going to see about another problem from a lead code. Here it is. Now the the question number 8 is 169, and the name of the question is majority element. Here it is majority element. Okay, now let's read this and understand what exactly the question is talking about, what is the problem statement, and then we'll go with the logic and then understanding the question and then code implementation. Now, given an array nums of size n, return the majority element. Okay, the majority element is an element that appears more than n by 2 times. Okay, you may assume the majority element always exists in the array. So here, it means it simply means that we need to find the majority element. See here, for example, this is the input. Now in this 3 2 3, so it means by seeing only we can say that this is a majority element, but there is one condition. The condition is the total length of the array, whatever the majority element is there, it should be greater than half. So what is the meaning here is like total, what is the length here? Total 1 2 3, so 3 by 2 it is 1.5. So 3 is occurring two times, so we can say 3 is the answer. In the similar way here, total, what is the total length of this array is total number of elements: 1 2 3 4 5 6 7. So 7 divided by 2 is how much? 3.5. So more than that it is 4. 2 is occurring 4 times, so it is more than half. So this is the main important here, which is occurring more number of times. And here is one formula is also given, one logic we can take this into consideration while solving the. And one more thing, it is given that the majority element always exist in the array. It means it should always there should be a element which should be more than half of the elements. Yeah, that is what the case here. Now to explain, to solve this, we can go with many examples, such as here, for example, we can go with a dictionary, means hash map, we say that. So for example, if it is like the same question here, I'm taking this even. So here in this I can just take a 3. 3 is repeating how many times? One time. Again 2. 2 is repeating how many times? 2 is repeating one time. Now again 3 is repeating two times, so I'm just taking two times. So here I'm just forming it what? Key and value. Key and value. So this is my key, 3 is my key, and 2 is my value. So in this way we can traverse this total dictionary, and we can find out this maximum occurrence. But what is the problem here is one more thing it is there here that we need to notice. The constraint is given. See, could you solve the problem in the linear time? It is saying linear time means, and in big O of one space. So what exactly it means is big O of n time and big O of one space, constant space. But here it will take a space. Yes. So this is not going to satisfy whatever here we are giving the space. Okay, so now let's see one more algorithm which which properly talks about how we can solve this problem. So here, yes, the name of the algorithm is Boyles-Moore voting algorithm. Okay. Now, what happens here is initially this is my array, and let's see what is the size of the array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total it is 16. Okay. Now I need to check which element is more number of time. So to check that we can directly count also. Let's see, let's count the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 is total 9 times occurred. So directly I can say that 5 is the maximum number. But we need to check that whether it is satisfying the condition or not. So what is the condition it has to satisfy? The condition is n by 2. So total it is what? 16 by 2 is 8. More than 8. So 5 is occurring 9 times. So it means what? 5 is exactly satisfying the conditions. Fine. Now how we are going to do with the help of this Boyles-Moore voting algorithm? Let's see. So what I will do is whenever the count is initially is the count is 0 here. So I'm just taking this is as a 0 initially. Let me change the color here. Initially it is 0. Yes. Now, and one more here also I can take here. So initially my this candidate, I'm just taking this candidate also 0. So I will just help you how why I'm just taking this. So initially, uh, yeah, what I need to do is I need to traverse 7, this 7 till here I need to go. So now a count is what? Initially the count is 0. When the count is 0, yeah, so we are just going with a 7. So now I'm just, this pointer is pointing to the 7, and at this time the count should get increase. So what I'm doing here is first it is 0, and at the time of 0 the control or the arrow is pointing to 7. So what I'm doing is when it is a 0, count is 0, at that time I'm just updating my candidate because this time it is 0. So I'm just updating the candidate as 7. So what I will do here is I will just remove this 0, means I'm just striking it, and here what I can write, I can take that 7. So 7 is here. Candidate means it's just an element, that's it. So 7 is here. Now now what I will do is we'll shift this arrow here, from here we'll go with another yeah, when it was here I need to also increase the 0 because the count I should. So what I'm doing here is the main Boyles-Moore voting algorithm talks about this. Whenever the element if I see the same element I need to increase the count. Okay. And whenever I'm seeing different elements then I need to decrease the count. Okay, increase and decrease, increase and decrease, that's what we need to do. Then when at the time when it becomes a 0, it means what? It has balanced, there is nothing maximum. So at what time it is getting 0, in that case we need to update the candidate a variable. So now here I'm just cancelling this 0, and then here it is 1. 1 got. Yes, I'm just updating this 0 as 1 because the count of 7 is 1. One time it occurred. Now here I'm just going with this again 7, and this time what happens? This count will become 2 because 7 7 2 times. So count is 2. 2 here, 2 times. Fine. Now after this again I need to, I'm just traversing here, again it is 5. So what does it mean? I need to decrease now. So let's reduce this. It will become what? 1. It becomes 1 here. Yes. Now again, this arrow, again I need to move this arrow to 7. Now this time what happens? This time again it becomes, yes. So here, yeah, it becomes 2. 2. Why it becomes 2? Because it's found the same number which is there in the candidate 7. So it is only checking for the 7, and if any other elements are there, then it is making them as, it is reducing the count. So now it is, now again let's move to the next one here, 5. So 5 means what? I need to cancel this 2 and I have to reduce it. So I'm just reducing it, and it should be like 1 is reduced, so it is 1. Now next one is, again I need to move this pointer to 1. So 1 is also not 7. So 1 is also not 7, and 5 is also not 7. That is the reason we are reducing it. So 1, again I'm just reducing this. I'm just updating this count. Now this time the count will be how much? The count will be 0. So here it is 0. Now one thing we need to notice is, yeah, the node point is from here up to here. Okay. In this array, what happens is, total what is the length of the array in this? 1 2 3 4 5 6. Okay, so 6 means we can see that maximum number of elements is 7. So why don't 7 be a maximum number? But 7 is a maximum number. If it is a maximum number, we should not get here 0. Okay, but now we got 0 means both got balanced. How? Because what exactly it's talked, n by 2, right? More than n by 2, more than half, the element should be, the maximum element should be present more than half time. So total it is 1 2 3 4 5 6. 6 by 2 is 3. So more than 3, at least 4 times, then we can say that yes, 7 is the maximum number. So now it is 0. We got here 0. So when I got here 0, now what I need to do is, I got my 0, first 0. Now it has to be update the candidate. Candidate will be getting updated now here. So it will be updating to the next one. When I'm going with this here, yes, I'm just going here 5, and then here in this candidate, 5 is getting stored now. 5. Let me go with a black. Okay, so now what happens, this 0, because now at this time, whenever it sees 5, it will increase. Whenever we access another number, then the count will be reduced. So now let's go with this. It becomes 1 here, because of 5, and then again we need to move it towards 7, here. Now when it is up to 7, now again what happens, again this in the candidate it is only 5, so we are only looking for 5. Whenever there is a 5, we have to increase. If any other number is there, then we have to decrease it. So now what happens, we need to remove, and it will be like 0 again here. So this time again I got 0. Yeah. So now what happens, when it is 0, then again I need to move this one towards another one, 5. So here also it is balanced. See, here also it is like 5 and 7, both are balanced, so there is no maximum number here in this. And again next one is, see, I'm just going with another one color, and here 5 5 7 7, here also it is balanced. Okay, so here also it is balanced, means it will be 0 only. But after that again I'm just updating this candidate with 5 only. So whenever it is going till here, Up to here it is balanced. So 1, 2, 3, 4. Up to here I got what? 4 I got. So I'm just updating this 0 with a 4. With a 4. Yes. So here I got 4, but now we are mainly concerned about this. We are mainly concerned about the candidate, that is 5. So 5 is the one which we are looking for. So now here we are not getting any 0. If I get a 0, it means same. But here I got 4. 4 times I got which one? Candidate 5. So it means I'm getting whichever is maximum number. Fine. So with this one idea you got, and the same logic, let's implement the same thing in a code. So let's see here. This is the code. In this, first what I need to give is candidate is equal to what? I'm just taking as none, and then count is equal to 0. Now for I need to run the for loop num in L. Okay, so what I'm doing here, I'm just going one element till last. Now here I'm just checking a condition. If count equal to 0, if the count is 0, then what I'm doing here, if my count is 0, then I'm updating it, right? I'm updating with a number. So I'm just taking the candidate is equal to, in candidate what I'm storing in this. So I'm storing this num, whatever I'm getting this 7 is got stored. Now here we need to check one more condition. I need to check if my num, see here, if my num here, this num or whatever here is 7 is equal to candidate. If it is same, then we need to increase the count. So num equal to candidate, then count we have to increase plus equal to 1. If not, else decrease the count minus equal to 1. That's it. So now let's print. I need to print what? Candidate. And here total how many 7s are there? 1, 2, 3, 4, 5, 6, 7, 8. And here I'm just giving 7. It is 9. So it is giving me the answer. 7 is the answer, guys, correct. But I need to validate also. I need to give that condition even. How to get that? For example, if I am giving here something else like 1, it will not give me the correct answer. So to get a correct answer, we have to make some modification. Like for example, if inside this if, I just wanted to give a count. If the count of occurrences is greater than n by 2, okay, that condition L dot count of what? Candidate is greater than length of, which length? L, yeah, length, yes, length of by 2. Yes, if it is more than length by 2, then we can say that we are printing the candidate. Print candidate, else we can just print no maximum element exist. No maximum number exists. Okay, so now here let's see what is the output here. I'm getting 7, and here if I write 1, now what happens? No maximum number exists, because 7 is just 8 times, but we should get more than 8 times. So this is the code. Now this one I'm just going to copy it, yes, here. So let's copy this code here and check whether it's working or not. Yeah, I'm just arranging them in a order. For, and then if, here it is, this candidate is inside the if block, and here it is, if is here, and increasing the count, else count is here. That's it. But now, one small thing is, for num in L. So L we are not giving here. So just I am not giving any test cases here, like any testing thing I am not giving. So what I need to do is, what is this L? L is nothing but, here I am just taking here nums. Nums, fine. So let's see the, let's run this one. Yeah, I'm getting something different answer. Let's see how, where we have gone wrong. Num in nums. Okay, we need to return, right? So we need to return it also. Return, because we are using function candidate. Candidate, yes. Now let's execute it again. Yeah, it accepted, and I'm just submitting it. So that's it, guys. It's successfully, it's submitted here. You can see it. So that's it. So if you have any doubts, you can just comment, and tell me what is the what would be the time complexity of this code. Obviously, it is given in the linear, so it is linear. So that's it, guys. Thank you for watching, and till then, take care. Bye bye, guys.